Hello, my name is Ruth Wood from the University of Manchester. And I'm going to provide a brief overview of what we do and don't know about climate impacts on infrastructure in cities, drawing on work with my colleagues David and Lee from the University of Birmingham and ideas from John Dora of the Infrastructure Operators Adaptation Forum. So firstly, I'd like to give an overview of how we can look at the impacts of risk of climate change on infrastructure. So if we start by looking initially at different types of climate variables we can expect to change. So average temperatures may change in time, wind speeds may change, levels of rainfall, sea level, combined with knowledge of the potential magnitude or frequency of more extreme events, such as heat waves, floods, storms, and sea surges. And we'd assess firstly how these present a risk to the performance of different pieces of infrastructure. So here are some examples from power networks, but you could equally apply this framework to other forms of infrastructure. So all infrastructure is designed to operate within specified weather or climate conditions. And outside of these, it may fail or it may not function as efficiently. And the impacts on the performance of these individual assets, such as impacts of increasing temperatures on the overheating of overhead power lines, impacts of floods on power stations, or the impacts of high wind storms on the toppling of pylons, all these have a knock-on consequences to the performance of the network as a whole. Through, for example, reduced transmission capacity during hot weather, reduced generation capacity of supply, or loss of power to an area. And the broader effects of this depend on how the network can cope. Is there sufficient spare capacity available? Are there alternative routes for power to be supplied? And it may also depend on how many assets are affected at one time, where they are, and how critical the asset that is lost is to the network. It's also important to understand as well how quickly that asset or outage might recover. The effect also influences a range of interdependent sectors. So power supply, for example, is used in our communications technology and transport. And as well as relying upon them to recover, it's how they are also affected by losses or outages. So it's a combined effect of both of these factors, loss of power supply in this example, and also the potential loss of interdependent services that in combination affect both social and economic activities. And arguably the functioning of our cities is supported by a range of different infrastructure, from energy, transport, waste, communications, and waste. So what do we know about impacts of 3 degrees C? So we know how different types of infrastructure are expected to perform under different weather conditions, because that's what they were designed initially to do. Cities, we also know how cities can be affected by the related conditions. So how people in cities cope with heat waves, often exacerbated by the urban heat island effect, the existing vulnerabilities and the ramification that causes for people, to flooding from different sources, and how storms and high winds affect different areas, be it exposed roads or high-rise buildings and canyoning. So this information is useful to understand how future climate could therefore influence the operation of cities, and how they currently cope with these extreme weather events can give us an insight on how we might adapt and cope with these events in the future. In principle, infrastructure networks in cities are much more able to manage losses of individual assets because there is generally more designed in redundancy in those systems. If one power cable goes down, there might be another way of supplying that area. Or if one particular transport route goes down, there are likely alternative routes for buses, or if metro or underground line fails, there are likely other ways of getting people from place to place. And that does tend to put city dwellers in a better position than rural areas that don't necessarily have those alternatives available to them. However, when events do happen to cities, there are an awful lot of people affected, and they can have significant impacts on people and the economy. There are now an increasing number of studies which use information on the current relationship between weather and disruption to evaluate how changing climate affects performance. And I'm going to give a few examples of these. So the first example here is a study by Tobutel, who assessed the impacts of 1.5, 2 and 3 degrees of warming on wind PV, hydro and thermoelectric plant outputs. The results are given in these graphs, and I've highlighted the results for the UK, which is on the far right of each plot. The impacts of 3 degrees are in this orange bar here, and you can see that power change is expected, or power output is expected to reduce from wind and PV by a small amount. Hydropower, not a lot of change in output, and thermoelectric, for the UK's case, this is predominantly gas-fired power stations which are fed by river water or use river water as a coolant. Their output in this study is anticipated to be reduced by around 14% under a 3-degree future. There are also studies such as this one by SayerZatal, which have looked at the impacts of climate change on flood risks to infrastructure. Now, this chart here shows the number of Category A infrastructure sites. Category A infrastructure sites are those associated with the energy supply and water supply. And this chart shows how many of these would likely be exposed to frequent flooding under both a 2-degree and a 4 degrees worth of warming. And it breaks down the results by a different area of the country. So you can see here that a high number of places within Yorkshire which would be affected by this. And although this study gives just 2-degree and 4-degree future, the relative magnitude of impacts at 2 and 4 degrees does give you an insight of where impacts associated with 3 degrees might fall. And this study also importantly didn't assume any further expansion of infrastructure, and also that continued current adaptation programs. So there are significant numbers of infrastructure at risk of frequent flooding that identified in this study. So although in general there are a growing number of studies which evaluate the effects of one climate impact on individual infrastructure components, assessing how their performance will change under that particular impact, such as changing temperature, wind speeds or flooding or flood risk. So similarly, city-based studies also examine individual climate impacts in turn, but there remain gaps. So firstly, a lot of our existing infrastructure is older, it's aging, and aging will affect its performance and response to weather. It may be being used very differently to how it was originally planned to be used. So 19th century bridges, for example, were not designed for modern vehicles or the volume of traffic now on the roads. And over the years, maintenance and repairs will have also altered performance, all of which means infrastructure may not respond in the way that engineering models might predict. Many studies now we've seen have assessed one type of climate impact on a particular component of infrastructure. More information is needed, for example, how series of events affect infrastructure's performance over time. So an example of this might be sequences of hot, dry periods followed by heavy rain on areas with clay soils, and what the impacts of this are on the potential failure of embankments or slopes, often used in our transport sector. Or we may want to know how infrastructure may fare in general all year round when exposed to the whole range of different impacts that you might see. So a more holistic appraisal. Many studies also focus on the impact of 2 degrees, but not many go above this. And as UK CP18 has relatively recently become available, not as many studies has yet used this data for appraisal. There's also not a lot of information publicly available on digital or ICT infrastructure and its exposure or vulnerability to climate change. Given we have increasing reliance on ICT for the coordination and control of infrastructure, we're increasingly using cloud computing, smart technologies, it's really important to have a better understanding of this sector's resilience to climate change. Finally, we've an emerging but not full understanding of interacting and cascading risks. This figure here from Mundy et al. Maps out the effects of two climate drivers, identified here in orange, extreme summer temperatures and a reduction in summer rainfall, and how these can go on to cause different impacts and different risks. The more arrows there are that you can see, the more interconnected and related these risks are to one another. And it's important to understand these interactions when assessing, in particular, the benefits of adaptation, as these benefits can go far beyond simply the savings to an individual infrastructure owner who might save costs for repairs or lost revenue. Moving to opportunities to progress. So as well as filling in our knowledge gaps, these include future-proofing all new infrastructure. There's some £640 billion of investment was committed to in the March budget, and this presents us with an opportunity to future-proof it from the start. And to do this, require updating of design standards and spatial plans, and to make sure that they take into account climate change, as well as ensuring each scheme has a climate resilience assessment. For existing infrastructure, the proactive development of climate risk assessments, inspection guidance and operating procedures and resilience plans gives an opportunity to better protect infrastructure and the people who rely on it to the impacts of climate change. And finally, to increase our understanding of cascade effects and incorporating these wider impacts into development of adaptation pathways. It's a huge opportunity. This slide gives an example of the processes involved in developing an adaptation pathway. And these provide opportunities to progress the incorporation of climate information into much longer term plans for infrastructure development and better protect infrastructure and cities and their interdependencies from all climate impacts. So considering the range of different climate impacts a city or part of infrastructure might be exposed to, and ensuring that they're all taken into account when developing our adaptation planning. Thank you very much.